Okay, I'm just going to show you a couple of special case systems where some different things happen. We're still going to use the same processes. Either we will graph them, substitution or elimination combination. I'll try to show you both ways on each one of them so you can see what happens because they are special cases. They're different and they produce a different type of system. One that we talked about in the very first document that I told you to be familiar with, but not any that we've solved. So this is topic 1-5, and this is special cases. Special cases. So if you want to look on in your handouts, you'll have those. And it'll be labeled as 1.5. Okay, here's the first one. 2x plus y is equal to 3, and 4x plus 2y is equal to 8. And we want to solve this system. What I want to do is I want to use combination to solve this system. Elimination combination, because I can see that when I look at this y right here, if it was a -2, it would make these two things drop out. So I'm just going to make it a -2. I'm going to multiply this entire top equation by -2. So that I'm going to rewrite it down here. -4x, because I'm multiplying. Okay, and then -2y is equal to -6. Now don't ever forget to multiply this one. You also have to multiply this side by the -2 or whatever number you're multiplying by. Be sure you don't forget. Then on the bottom, I'm going to have 4x plus 2y is equal to 8. I didn't have to multiply it by anything. Now when I get ready to add these together, look what happens to my x's. They drop out. And my y's drop out. So I have nothing left over here. And -6 plus 8 is 2. Well, ask yourself, is that a true statement? Is 0 equal to 2? No, it's not equal to 2. No, okay? So if that's not true, then there is no solution to this system. These two lines were parallel. If you had put these into y equals, you would have seen that they both had a slope of -2. And so they're parallel lines. There is no solution. They never cross. If you had graphed them, they would have never crossed. So that's special case number 1. No solution. Now I'm going to work this very same special case. Instead of using elimination combination, I'm going to use substitution, just so you'll see what happens and you know that you'll get the same answer either way. So here we are doing the exact same problem. I'm just going to do it using substitution in case you wanted to use that method. Because sometimes when you're working these problems, I'll give you the choice. Okay, so for substitution, I'm going to start with this one right here. Okay, and I'm going to solve it for y. Y is equal to -2x plus 3. Because remember, in substitution, we have to set one of the equations equal to x or y. It's easier to set this one equal to y because y is already by itself. It has no coefficient. Now I'm going to come down here, and in the other equation, wherever I see a y, I'm going to replace it with this right here. So here we go. 4x plus 2 times, what is y equal to? Well, we just found it. There it is, -2x plus 3. And then I finish out my equation, equals 8. And then I'm going to solve 4x, and then I'm going to multiply. That's -4x. And then I'm going to multiply, and that's plus 6 equals 8. Well, look what happened again. The x's go, and I get 6 equals 8. Anytime all your variables drop out, you make a decision. It's not true, so there is no solution. And remember from that very first document I put in here for you to know, I told you that when there's no solution, the lines are parallel. So we have parallel lines. Because remember, you're either going to get one solution for intersecting, no solution for parallel, or all solutions for coinciding. This wasn't true. It's no solution, so we know that our lines are parallel. Now that's the same problem worked two different ways. Okay, now then, I'm going to work a different problem and show you what happens. And we'll go ahead and use combination elimination on this one, I guess, and see if you like that. And then we'll do it with substitution, and then you can decide which way makes more sense to you. Okay, combination elimination. Let's go ahead and multiply the top one times -2, and that's going to make the y's drop out. So we have multiplying the top, that's -4x minus 2y equals -6. And then we don't do anything to the bottom because our y's are going to drop out. And look what happens when I add them together. The x's drop out, the y's drop out. We have 0, and the other side drops out. Now all the letters dropped out. So you have to make a decision. Does 0 equal 0? Yeah, sure it does. That's true. So this is all solutions, or infinitely many solutions, infinite. And remember, when that happens, that means our lines are coinciding. Okay, so that's special cases, either no solution because they're parallel and the statement is not true, or all solutions because the lines are coinciding, and that's when the statement is true. Okay, so I will work that one more time, the same problem, but this time we'll use substitution. I think most of you are going to prefer elimination, but I want you to have that choice. Okay, so if we're going to do substitution on this one, I'm going to set this one equal to y. Y equals 3 minus 2x. And I don't have to put it in mx plus b form, just have to get the y by itself. Now then, I'm going to go down here to this equation, and wherever I see a y, I'm going to put that whole value right there. So 4x plus 2 times y, and what does y equal? 3 minus 2x equals 6, because I'm plugging it into that equation. So 4x plus 6 minus 4x equals 6. The 4x's cancel, and I get 6 equals 6. So I get to stop at that point and make my decision. Is that true? Sure it is. So that means that we have a special case, and it's infinitely many solutions. Or you can say all solutions. And that means my lines are coinciding. It's the same line. Okay, so those are special cases that don't always happen, but when they do, you know that it's either going to be all solutions if it's true statement or no solutions if it's false. If it's no solution, the lines are parallel, they never cross, and if it's true and it's all solutions, it's just coinciding, one line on top of the other. Okay, that was topic 1.5, and I believe that your worksheet is A1-5.